Hello everyone. Today we are going to discuss about work done and energy. We will also talk about the formula of work done and its units. Let us understand the concept of work done by a very easy example. Consider a straight road or a straight track in which there is a toy car. So this is a toy car and there is a small hook. With this hook there is a very long thread or very long rope attached. This car is assumed to be at rest at time is equal to 0. So its speed is 0 meters per second at time is equal to 0 seconds. So the moment you start the stopwatch, at that time the time is 0 and the speed is 0. So this car is assumed to be at rest. Now I am supposed to exert the force in this direction. When I exert a force F, I will see that this car will change its state from rest to motion. So this car will start moving. After 5 seconds, the car is expected to be somewhere over here. Still we are exerting force F. We are not going to leave this car as it is. You are supposed to keep on pulling this with a constant force F. The center of the car was here. This center of the car has reached over here. So we can say that this is the distance traveled by the car in a straight line, D. Suppose D is 10 meter and F is 200 Newton. Then work done is equal to force multiplied by distance. To be more precise, this is not the distance, but this is displacement. Now, this is the starting point. This one is the starting point. This is the finishing point. You draw an arrow in the direction of the motion of the car, and the arrowhead should be always towards the finishing point. This is the direction of displacement. So since we don't care about this much, it is because when a car is traveling in a straight line, distance and displacement both are same. The direction of force and the direction of displacement, as we can see, are same. So we are going to substitute this. The values over here, 200 Newton multiplied by 10 meter. Then 200 into 10 is 2000 Newton into meter. This Newton into meter is called joule. Joule is the SI unit of work done. Remember, you can use this formula only when F and D are in straight line. When they are both in same direction, then and only then we are going to apply this formula. If not, if the direction of F and D are not in a same line, then we will take up that part in our next video. Okay, so here unit of force is in SI units. D is also given in SI unit. So we are going to get our answer of W in SI unit. Had it been, F would have been in in dyne. This is the CGS unit of force, and D in centimeter, CGS unit of force. Then work done is equal to force multiplied by displacement. So dyne into centimeter. This is called erg. We can easily make out a connection between joule and the erg. Let us see that. 1 joule is written as 1 Newton into 1 meter. So 1 into 1 is 1, joule is Newton into meter. Okay, we know that 1 Newton is 10 raised to 5 dyne and 1 meter is 100 centimeter. 100 can be written as 10 raised to 2 centimeter. Now this is 10 raised to, when we multiply the two numbers and if we find the bases are same, then we have to directly add up the powers. Dyne into centimeter is called erg. So we have made a connection between the erg and the joule. So 1 joule is equal to 10 raised to 7 erg. This is the SI unit, this is the CGS unit. Okay, here this means that while I was pulling this car by a force of 200 Newton, I got tired. My body lost some amount of energy in doing some work. So I did a work of 2000 joule. That means my body lost 2000 joule energies in order to pull this car from this place to this place. You might wonder that at time is equal to 5 seconds, what is the speed? That again we will discuss in the later part of the video.